Good morning, fifth graders. Today we are on page 247 of your student journal and we are on Unit 11, Lesson 10. So we are still working on line plots. The only difference is that today's word problems are all going to involve some sort of division. So our objective for the day is today I will use division to solve multi-step word problems involving line plots. And I know that's a really long objective for the day. Pretty much nothing of it is new though. We're going to still have those multi-step word problems. We're going to have line plots. The only addition is now it's division. The last few times we've been doing this, we've been having more addition and multiplication. So our vocabulary is pretty much the same. There's nothing new here. The steps, they did kind of change them up a bit, but I don't think we're really going to worry about that too much. It says read the word problem, find common denominators if necessary, create and plot the measurements on the line plot. And remember when we did step 3, remember that we circled the greatest and the least. So we probably want to put that on there, like we could just say circle least and greatest. And then for steps 4 through 6, they separate them. I think it's all the same thing. Identify key information, solve problem, check for reasonableness, doesn't make sense. That just means solve the problem. That's one big step. That means once our line plot's done, we can jump in and start our problem. Okay, so ladies and gentlemen, I'm going to get started on my problem. And my first problem looks like this. It says, Dahlia and her 6 friends are at a birthday party. They want to be fair and make sure everyone gets the same amount of juice. Right now, they all have different amounts of juice. So they charted the amounts on a line plot. How can they redistribute the juice so that everyone gets the same amount? How much juice should each person get? Okay, so I do want to understand the story, but before I actually attack the problem, I'm going to make my line plot. So what I notice first is there are different denominators, 8s and 4s, which means my least common denominator is going to be 8. So I know 1/4 is the same as 2/8. That can stay, that cannot stay. 2/4 is the same as 4/8. 1/4 is the same as 2/8. 6/8 it's fine, 2/8 and 6/8. Okay, so now they have common denominators and let's see what our largest is. Our largest is 6/8 and our smallest is 2/8. Okay. Now, if I was making my number line by myself, I would probably start at 2/8 and end at 6/8. But because they've already given me a number line, I'm just going to start with 1/8 then. So I'm going to cut this into eighths. I might cut it in half first just to help me plan it out a little bit better. So I'll have 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, and 1 is the same as 8/8. Okay, when I do plot mine, remember I like to cross them off as I go so I don't accidentally miss one. So 2/8, 6/8, 4/8, 2/8, 6/8, 2/8, and 6/8. And I can double check that by counting 1, 2, 3, 4, 5, 6, 7, 3, 4, 5. So I have them all. Okay, so what's my word problem really saying? They're saying that these are the 7 cups of juice and they want to make sure that everyone gets the same. So how would we do that physically? If this was the real party, we would pour them all back in, add up what we have, and then pass them back out. So that's really what I'm going to do here. So if I have 3 2/8, that is 6/8 plus 4/8 plus 3 6s, 3 6 numerators, would be 18/8. And then if I add that together, I get 28/8. Okay, so I have 28/8. Now, there's Dahlia plus her 6 friends. So there's 7 people. So 7 people need to share this. Well, if I take my numerator and 7 people share that, well, I know that 28 divided by 7 would be 4. So each person's going to get 4/8, which is equal to 1/2. That would be my answer. Okay, let's see one more done. My next problem says, the Autoshop Recycles Car Oil. The table shows the different amounts of oil people dropped off on Tuesday. At the end of the day, the auto shop disposes the oil into 2-quart bottles. How many bottles can they fill? Okay, so when we look, first I notice denominators of 2 and denominators of 4, which tells me my LCD, my least common denominator, is going to be 4. So 1/2 I can say is the same, and I might just write it over here as is 2/4. 3/4 is fine, that's fine. Another 1/2 would be 2/4. Another 1/2 would be 2/4. And another 1/2 would be 2/4. Okay, so now I am ready to make my line plot. And my smallest one is 1/4 and my largest is 3/4. But because they gave this to me, I'm just going to use all of them. So 1/4, 2/4, 3/4, and 1 is the same as 4/4. Okay, so what do I have? I have a 2/4, a 3/4, a 1/4, a 3/4, a 3/4, a 2/4, a 1/4, a 2/4, a 2/4, and a 3/4. And again, if I want to count, there was 10 original ones, and I have 2, 3, 4, 5, 6, 7, 8, 9, 10, which just tells me I probably got them all. Okay, so what do I have? If I had 2 1/4, that would be 2/4. If I had 1, 2, 3, 4 2/4, so 4 2s would be 8/4. Plus I had 1, 2, 3, 4 3s would be 12/4. So I have a total of 22/4. Okay, what is my problem asking me though? My problem says at the end of the day, the auto shop is going to take all this oil that I have and dispose it into 2-quart bottles. So they're going to take this, which is more than 2, and they're going to fill up as many bottles as they can. Well, a few lessons ago, I said there's something called in-out that helps me take improper fractions to proper. So I'm going to say 4 can go into 22 5 times. 5 times 4 is 20. And I'm getting 5 2/4. So that's how much oil they have. They have 5 2/4 quarts. Well, if the bottles each hold 2 quarts, 1 bottle is not going to be enough. 2 bottles will hold 4 quarts, but 3 bottles would hold 6 quarts. So they're going to need 3 bottles. That would be enough. Okay, so ladies and gentlemen, let's try some together. Okay, so we are on page 248, and here's our first problem. And it says, Mateo and his 8 cousins broke a piñata at a party. Right now, all have different amounts of candy, but they want to share it equally. Each cousin recorded the weight of their candy. How can they redistribute the candy so everyone gets the same amount? How much would each person get? So this kind of sounds like the problem I just did for you with the juice. Okay, so if we look at our denominators, I see 3, 6, 3, 6, 3, 6, 6, 3, 3. So my LCD, or least common denominator, is going to be 6. So we know that 1/3 is the same. I'm going to write it up here because they didn't give us a lot of room. 1/3 is the same as 2/6. That one's good. 2/3 is the same as 4/6. That's good. 2/3 is 4/6. That's good, that's good. 1/3 is 2/6. And 2/3 is 4/6. Okay, so now we're ready to make our line plot. And it looks like I'm gonna do it in half and then cut these into kind of like thirds. So I have 1/6, 2/6, 3/6, 4/6, 5/6, and 1 is equivalent to 6/6. All right, so we have 1, 2, 1, 1, a 4, a 5, a 4, a 1, a 5, a 2, and a 4. Okay, they really did not leave us room to work, so we'll have to kind of be creative. 2, 1, 6 would be 2/6. 2, 2, 6 would be 4/6. 3, 4, 6 would be 12/6, and 2, 5, 6 would be 10/6. So I have 6 plus 12 would be 28 plus, let's see, actually 6 plus 12 would be 18 plus 10 would be 28. 6. Okay. So we have to think about this. And I'm wondering, boys and girls, if I somehow made a mistake, because that seems like that's going to be a weird number to have. I might go back and check. So I had a 2/6, a 1/6, a 4/6, a 5/6. Okay, so if I had 28/6, now let's go back and read our problem. If we had 28/6, what would be our problem there? Well, our problem is that we have our people. Okay, so our people are Mateo and his 9 cousins. Mateo and his 9 cousins. So let's figure that part out. Well, we have, that's going to be kind of an awkward thing to divide here. So we have 28/6 divided by 9. Okay, when you divide fractions, and I'm going to have to come up here and do it, 28/6 divided by 9, because 28 is not going to divide nicely by 9, so it's divided by 9 over 1. There's something called the reciprocal, which you have not really done this, but what it is we call it KFC. We're going to keep the first problem, the first. We're going to flip the second, so we're going to get 28/6. We keep the first, we flip the second to 1/9, and then we C is change the sign. And I'm surprised this problem's in here, ladies and gentlemen, because this is not something that I know you've learned. So KFC again means keep the first, flip the second, so 9 over 1 became 1 over 9, and C is change the sign. So now I have 28 times 1 is 28. We really don't have enough room. 6 times 9 is 54. Now, I'm glad I'm doing this one with you because it's so tricky. If I was to simplify this because they're both even, I could divide them both by 2 and I get 28 divided by 2 is 14. 54 divided by 2 is 27. I will make sure you do not have one that challenging on your test, ladies and gentlemen. That was a little bit unfair. Okay, let's look at our second problem. Mr. Soto's students painted a background scene for a play. After the class ended, he charted the amount of black paint students didn't use. Mr. Soto wants to store the unused black paint in 4-ounce containers for a future art project. How many containers can he fill? Okay, so if we look at the denominators, I see 2s and 4s. So I know my LCD, or least common denominator, is going to be 4. So the 1/2 will be 2/4. That's fine, that's fine. This 1/2 also has to be a 2/4. I can put it out there. Okay, so let's make our line plot, and it's going to be by fourths. So we have 1/4, 2/4, 3/4, and 1 equals 4/4. And what do we have? We have a 2/4, a 1, 2 1/4, I can do those together, a 3/4, a 1, a 1/4, a 3/4, a 1, and a 2/4. And we can stop and count them just to make sure that we have them all. Okay. So now let's kind of add what he has. He has 3 1/4, which we'll have to find a place to add, means 3/4. He has 2 2/4, which is 4/4. He has 2 3/4, which is 6/4. And 3 4/4, or 3 1s, we could just say is 3. Okay, so if we add this up, we get 3 plus 4 is 7, plus that is 13/4, and we have 3. So 3 and 13/4. So we could use in and out for this, in and out, and that's going to be really squished, ladies and gentlemen. I might have to look down here. So 4 can go into 13 3 times, and I am getting 3 and 1/4. But we already had 3, so I actually have to add that together. So my answer so far is 6 and 1/4. But that's not what the problem's saying. The problem says that that's now how much ounces of extra paint he has, but he wants to put this paint into containers that are 4-ounce containers. So how many containers can he fill? How many containers is he going to be able to fill or need? Well, definitely 1 container is not going to be enough. So he would need 2 containers So part of our answer could be just 2. He needs 2. If we wanted to know exactly how many, then we would have to divide that by 4. Okay, so that's where this gets a little tricky, is that we'd have to divide that by 4 to get our exact answer. Okay, so we could say we need 2, and if we wanted to get our exact answer, that's going to be a lot trickier. I'm actually going to get some paper and kind of show you how we would do this, and if you want to get some paper. So it would be 6 and 1/4, okay, we'd have to do that, divided by 4. Now, just like with multiplication, we can't have a mixed number. We have to have only fractions. So we would say 25/4, because 6 times 4 is 24 plus 1, divided by 4. And then if you want that practice of that KFC again, I could keep the first, flip the second, which the second is 4/1, so it would be 1/4, and change the sign. So I am getting 25/16. Do you see how much work these are, ladies and gentlemen? Which is, when I go through the steps, it's 1 9/16. So that would be the exact answer of how much he could fill, 1 and 6/19. So it's a lot of work to try that. I encourage you to try that KFC. Keep the first and flip the second, and just come back to this one to keep helping you. Please know, ladies and gentlemen, this is kind of a hard first lesson, but we will be practicing more tomorrow. And today you only have 2 problems to try, so just do your very best. Have a wonderful night. Bye.